So welcome to Sakalavidya educational channel. So welcome to Eamcet Andhra Pradesh and Telangana and also JEE means classes. So today we talk about the vector algebra chapter. That also under vector algebra we are going to discuss clearly. We talk about dot product, that is the scalar product. Okay, I welcome you all once again. First let us go by the concepts, then we will switch over to the problems. So first let us move to the first concept. Am I audible to you? Yes or no? You need to chart. Right. Let A bar and B bar be two non-zero vectors. Okay. Right. Shravan, Gion, welcome to our classes. And theta be the angle between them. Clear? Right. Then scalar product or dot product. Scalar product or dot product. Okay. Chaya Devi, welcome. Dot product of A bar and B bar. These two are the vectors. A bar and B bar denoted by A bar dot B bar and A bar dot B bar is defined by A dot B is equal to mod A mod B cosine of angle between A bar comma B bar, that is cos theta. So this is the definition of the A dot B. I hope it's very clear to you now. So for example, A bar comma B bar be two non-zero vectors and theta be the angle between them, then the scalar product, or it may be called as dot product, of A bar and B bar denoted by A dot B and defined as A dot B is equal to mod A into mod B cos theta. So clear now? As A dot B is equal to mod A mod B cos theta, then we can find out cos theta value. We can write like this also. Cos theta is equal to A dot B by mod A mod B. Clear? So now you can remember like this. So what is the use of this dot product or scalar product? It is used to find out angle between two vectors. The angle between two vectors. That means two non-zero vectors. So can be evaluated, can be found using this formula. So cos theta is equal to A dot B by mod A mod B. Okay, I hope it's very clear to you. Now let us move to second concept now. Let us move to second concept. Are you there? Yes or no? So second concept. So for example, let I comma j comma, they are the unit vectors, I cap, j cap, k cap. Generally you can put like this also, j cap, k cap, be unit orthogonal. Orthogonal. What do you mean by orthogonal? Just think for a while. So before going to complete this one now. Orthogonal vectors. Orthogonal vectors. So what do you mean by that one? I comma j comma k are unit orthogonal vectors. So that is, so we define like that. So being unit vectors, that is actually modulus of I is equal to modulus of j is equal to modulus of k is equal to 1 unit, and also the angle between I comma j, angle between I comma j denoted by like this, equal to angle between j comma k and angle between k comma I is equal to 90 degrees. Orthogonal means they are mutually perpendicular one another. So one another. So then what do we have? So my dear students, you remember I dot I is equal to mod I into cos 0. You will be getting I dot I, j dot j, k dot k. Obviously you need to write 1. So next you need to write like this, I dot j, j dot k and k dot I. They are perpendicular, so that is 0 you will be getting obviously. J dot I, k dot j, I dot k is equal to 0. So we can remember this one as using a table. So let us prepare the table now. So with the help of this table, easily the dot product, so between this I comma j comma k, easily we can remember. So now this is I, j, k, this I, j, k. So now this is the dot product. Dot product. Write down I, j, k, I, j, k. So my dear students, remember I dot I is 1, I dot j 0, I dot k 0. Just like a unit matrix you will be getting j dot I 0, j dot j 1, 0. Here also k dot I 0, 0, 1. Clear now? I hope it's very clear to you. Right. So let us move to yet another very important concepts need to be discussed now here. Properties. So third property. Third property, let's have a discussion on third property. For example, if a bar is equal to linear combination of I comma j comma k, but any vector can be expressed in terms of I comma j comma k, that is called linear combination of I comma j comma k. For example, a bar is equal to a1i. This is the actually a1 is the component of I. So this is actually say a2j, a2 is the component of j, a3k. So this is the linear combination of I comma j comma k. And next we have, for example, in the similar lines, if b is expressed as a linear combination of I comma j comma k, so b1i plus b2j plus b3k, b3k. So then, so this is very important. This is also very important for even physics chapter also. So first concept, let us write a dot b. How to evaluate a dot b? So very simple. As we have I dot I1, j dot j1, k dot k1, you will be getting a1i dot b1i. That is equal to, you will be getting a1 into b1 plus next a2 into b2 plus a3 into b3. Clear? Now in the similar, so in this actually we can find out a dot b here, a dot b. For example, second point, what is a dot a? What do you write a dot a? Just think, a dot a means you will be getting a1 square plus a2 square plus a3 square you will be getting. So a1 square plus a2 square plus a3 square is equal to, my dear students, you remember, so just what is the modulus of a bar? Modulus of a bar is equal to modulus of a1i plus a2j plus a3k. So in the first chapter, properties of the vectors, we have discussed how to evaluate the modulus of the any vector, that is equal to under root of first component square plus second component square plus third component square. So that means a1 square plus a2 square plus a3 square nothing but mod a whole square. So whenever mod a whole square is there, we can write a dot a, we can write. If a dot a is there, you can write that is mod a square. Clearly you note down a dot a is nothing but modulus of a whole square. You remember this one. This is very important result, right? So next let us move to yet another result now that we need to discuss. So for example, already we had a discussion how to find out the angle between any two vectors. Any two vectors. Are you there all of you? Just let right a bar is equal to a1i plus a2j plus a3k and b bar equals to b1i plus b2j plus b3k and angle between a bar comma b bar denoted by this one equal to theta. Then cos theta is given by cos theta. So cos theta is equal to a dot b by mod a mod b. What is a dot b? A dot b is equal to a1 b1. Already we have evaluated a2 b2 and next a3 b3 upon modulus of a. Modulus of a is equal to root of a1 square plus a2 square plus a3 square. Clear? Under root of here modulus of b, that is b1 square plus b2 square plus b3 square. Clear? So in this way we can find out the cos theta value. So now how to determine the sign of a dot b? Sign of a dot b means whether a dot b is greater than 0, whether a dot b is less than 0. So when does a dot b become 0? If a dot b becomes 0, what is meant by that a dot b? So that we need to have a discussion now clearly. So next let us move to the fifth point now. Fifth point. So for example, you can say let the angle between a bar comma b bar is equal to theta. Clear? So then first one, a dot b is greater than 0. Suppose a dot b is greater than 0, a dot b is positive. If a dot b is positive, if and only if theta is less than 90 degrees, the angle will be less than 90 degrees. So that means acute angle you are going to get it. So second concept. For example, if a dot b is less than 0, a dot b is less than 0 means if and only if theta is greater than 90 degrees. That means obtuse angle you will be getting. And one more very important. This is very important. Please remember. Suppose a dot b is equal to 0. So that implies here a bar perpendicular to b bar. If the two vectors are perpendicular, then their dot product or scalar product is 0. If the dot product or scalar product is equal to 0, obviously a bar comma b bar are so mutually perpendicular each other. So if provided that a bar comma b bar non-zero vectors, that you remember. So here we can write a bar is perpendicular to b bar. I hope it's very clear to you now. Okay, right. So next let us move to next concept. Next sixth concept. So let's have a discussion on sixth concept. If a bar and b bar are parallel vectors, and are in the same direction, and are in the same direction, in the same direction, same direction, same direction. So then a bar comma b bar are like vectors. Like vectors means they are in the same direction. Like vectors. Okay. Jyoti, welcome. Then what is a dot b? What is a dot b? See, in this case actually vectors are like this. Parallel vectors, same direction. This is a bar, this is b bar. Then what is a dot b? See, then a dot b is equal to, we can write mod a and mod b, that is cos 0 is 1. So this is actually like vectors, you need to take care plus sign. A dot b becomes mod a plus, sorry, mod a into mod b. Mod a into mod b. Clear? Srinu, welcome. Right. And moreover, for example, if a bar and b bar are parallel, but their directions may be in opposite direction. Okay, and are in the opposite direction, that means a bar comma b bar are unlike vectors, not like vectors, unlike vectors. Then what do you say about a dot b? How do you interpret? So a dot b is equal to obviously negative mod a mod b. So that means actually this time the vectors are like this. They are parallel, a bar and b bar. They have the different direction, opposite direction. So that means mod a into bar b negative of. And one more concept. For example, if a bar comma a bar and b bar are unit vectors. Unit vectors means whose moduli is 1. Unit vectors. Then directly we can write a dot b, very simple manner. Mod a is equal to 1, mod b is equal to 1. So obviously the angle between cos theta, it becomes cos theta. Directly we can write cos theta. Here cos theta is equal to a dot b because mod a mod b is equal to 1. Right. Very important concept. So let's have a discussion. That is the 9th one. If a bar comma b bar are any two vectors, then a dot b is equal to 0. Then what do you say? Then how do you interpret it? So you need to chart a dot b is equal to 0. A dot b is equal to 0 means either a may be 0 or b may be 0, 0 vector, or if a bar comma b bar are non-zero vectors, a bar perpendicular to b bar. So any two vectors given means actually the three cases will arise. If a dot b is equal to 0, if a bar comma b bar are any two vectors, the three cases will arise. The first case is a bar may be 0 or b bar may be 0, or we can say that a bar perpendicular to b bar. And moreover, very important, you remember, if a bar comma b bar are two non-zero perpendicular vectors, then always we get this one. Then A dot B is obviously 0. This you remember. The specific case you can remember. A bar comma B bar, two non-zero perpendicular vectors, then A dot B is equal to 0. Or we can say that if A dot B is equal to 0, then A bar comma B bar are orthogonal vectors also we can say. Orthogonal vectors also we can say. Right. So next concept. This is very, very important concept. Let A bar and B bar be two non-zero vectors. Two non-zero vectors. Vijay Kumar, welcome. Then component vector of B bar on A bar, or this is also called the orthogonal projection, of B bar on A bar. This is very, very important, my dear students. Please note down in your notes. This is very, very important, and based on this, the many questions may be asked in different competitive entrance examinations. JEE means Eamcet, PGT and TGT also. So component vector, orthogonal projection, both are same. You remember, component vector and orthogonal projection, both are same, of B bar on A bar. So that is equal to, you remember, B bar dot A bar, dot product between A bar and B bar we need to evaluate, divided by mod A square into A bar. So this is the scalar multiplied by the A bar you will be getting. What is the scalar here? B dot A by mod A whole square dot A you will be getting. This is the, so component vector of B bar on A bar are orthogonal projection. So in the similar lines, in the similar pattern, you are able to find out the component vector of A bar on B bar also. So that also we can determine now. So next let us move to that one. Right. So next 11th one let us write. This is also very, very important. So component vector of A bar on B bar, or we can write, or the orthogonal projection of A bar on B bar is equal to. So what do you write? Thank you, Firoz Sheikh. Thank you. Welcome. So keep on watching. So thank you for your good feedback. So this is A dot B upon mod B whole square. This will be the scalar multiplied with B bar. You need to write it. I hope it's very clear to you. So you always remember, Nana, component vector means vector quantity, orthogonal projection also vector quantity. You remember, my dear students, like this. Orthogonal projection, component vector or the vector quantity, not is a scalar quantity. So I hope it's very clear to you. This is also very, very important. Very, very important. For example, you are asked actually length of the orthogonal projection. Length of the orthogonal projection means very simple, that is actually That is the scalar quantity you are going to get it now. So let's have a discussion on that one. So next, 12th point. Let's have a discussion on 12th point now. Right. And one more, in the direction of perpendicular to A bar also we need to discuss. That's also orthogonal projection. Okay. Now the orthogonal projection, the orthogonal projection, the orthogonal projection, the orthogonal projection of B bar in the direction perpendicular to that of A bar equals to thank you Firat, thank you, many thanks. So that means actually here what we need to do is now B bar minus orthogonal projection of B bar on A bar, we need to write it. That is B dot A by mod A square into A bar. So this is the orthogonal projection of B bar only, but in the direction perpendicular to that of A bar, not on A. So that means B bar minus orthogonal projection of B on A. So that we need to do it. So next let us write the 13th one. So everybody need to write down this one. You might have expected now how to write it. The orthogonal projection of A bar in the direction perpendicular to that of B bar. So what's your answer? What is your answer? Yes, you try yourself. A bar minus the orthogonal projection of A bar on B bar. That means A dot B upon mod B square. So mod B square into B bar. So let me write once again. This is mod B square. I hope it's very clear to you. Okay, right. So next let us move to the length of the orthogonal projection. Length of the orthogonal projection means that is a scalar quantity, and also it should be positive. Length is always measured in positive sense. Okay, let us move to 14th point. The length of the orthogonal projection of B bar on A bar. So not orthogonal projection or component vector of B bar on A. So this is equal to, you will write like this, modulus of B dot A by mod A. So this is the required one. So 15th one, the length of the orthogonal projection of A bar on B bar. So this equals to A dot B by mod B and modulus, because the length is measured in positive. Length is always positive. Length is always positive. And also scalar quantity. This is scalar. Clear? I hope it's very clear to you. Right. So let's have a discussion on properties of the dot product. Do you have any idea about the properties of the dot product? So properties plays major role actually. Yes, see, the scalar product is the scalar product is commutative. It obeys commutative law. Is commutative property. It follows commutative property. So what is commutative property? Very simple. That is A dot B is equal to, you can write B dot A. That means one application, let's have a discussion. For example, A bar plus B bar whole square is there. This is nothing but A bar plus B bar dot A bar dot B plus B bar. Because it obeys even distributive property also, so you can write like this, A bar dot A bar plus B bar, and plus you can write now B bar dot A bar plus B bar. So this is the application of this one. See, just you are going to get it. A dot A is already we have discussed, mod A square, plus this is A dot B, plus this is B dot A, plus B dot B is mod B square. My dear students, you just observe B dot A is same as A dot B. So we can write now, this can be rewritten as mod A square plus A dot B plus B dot A is nothing but using commutative property A dot B plus mod B whole square. So then what do we get it now? My dear student, just like A plus B whole square formula. So mod A whole square plus 2A dot B, A dot B plus A dot B, 2A dot B plus mod B whole square. Clear? So this is the application of this property during the problems in general. So in the similar pattern you can expect, that is A bar minus B bar whole square also. Okay, I hope it's very clear to you. In next 17th property, 17th one, the scalar product or dot product also, no problem, you can say. The scalar product is distributive. It obeys distributive property. Distributive axiom also we can say. Distributive over vector addition. Because we have been dealing with the vectors, we need to say that vector addition. So that means, Jayesh, welcome. So that is, we can write like this, A dot of B bar plus C bar. This we can write like this, A dot B plus A dot C. Clear? Or for example, B bar plus C bar dot of A bar. So this is the actually left distributive, this is the right distributive property. Radhika, this we can write B dot A plus C dot A. So both are same, no problem. It obeys even associative property also. Leave it to that one now actually here. And one more property. So if you multiply a scalar with a dot product, what will happen? Let us see. For example, here let L be a scalar, L A bar dot B bar. How do you write it? So this is very simple. You can write A bar common, A bar dot L B bar, you can write it, or L common out, we can write A dot B. Very simple. Clear? So here we need to specify that where L is a number, numerical number, or any real number. L is a scalar. Any real number is always a scalar. Clear? So next, inequality properties we need to discuss now. Inequality properties. This is also very important. A dot A. So my dear students, what is meant by A dot A? Now just we had a discussion. A dot A is nothing but modulus of A whole square. Modulus of A is nothing but length of the vector. Length is always distance. Distance whole square is always positive, you will be getting. So that means A dot A is always greater than or equal to 0. Clear? And one more thing. So modulus of A dot B, modulus of A dot B is always less than or equal to mod A into mod B. So one more property. So here modulus of A bar minus B bar. This is always greater than or equal to mod A minus mod B. So these are the inequalities properties. Suppose modulus of A bar plus B bar is less than or equal to mod A plus mod B. This is just like a triangle inequality, mod A plus mod B. Right, Jannavi, welcome. Right. So next, already we had a discussion now. What is modulus of A bar plus B bar whole square? This equal to, we can write mod A whole square plus mod B whole square plus 2A dot B. Just the previous case we have discussed. See, in this case we have the proof now. Clear? Just go through it. How to find mod of A plus B whole square? A plus B whole square is nothing but A plus B dot A plus B, that is mod of A plus B whole square only, obviously. Right. Thank you. Next, mod of A bar minus B bar whole square. This is mod A whole square plus mod B whole square minus 2 A bar dot B bar. So mod of A bar plus B bar whole square plus mod of A bar minus B bar whole square. Then what do you get? Add these two. Then what do we get? Add these two. Then what do we get? You expect it. What do we get? Sanjay, welcome. See, if you add these two plus 2 A bar dot B, 2 times A bar dot B cancel, you will be getting, this will be 2 common. So mod A whole square plus mod B whole square you will be getting. And one more important thing, so it may be applied to the even 3 vectors also. This is very important, please remember, 21st one. Mod of A bar plus B bar plus C bar whole square. This equals to mod A whole square plus mod B whole square plus mod C whole square plus 2 times of A dot B plus B dot C plus C dot A. But actually in competitive entrance examination, as far as this examination is concerned, actually Eamcet or JEE means other PGT and TGT examinations, one beautiful deduction you may get from this one. Suppose if A bar comma B bar comma C bar are 3 mutually perpendicular vectors. So that is, you can write A bar perpendicular to B bar, B bar perpendicular to C bar, and C bar perpendicular to A bar. So then you are asked to find out modulus of A bar plus B bar plus C bar. So that means, my dear students, remember mod A plus B plus C bar whole square is equal to, you can have mod a whole square plus mod b whole square plus mod c whole square plus 2 times of, here see, since a bar perpendicular to b bar, a dot b becomes 0. Since b bar perpendicular to c bar, b dot c becomes 0. Since c bar perpendicular to a bar, c dot a becomes 0. Obviously, this bracket a dot b plus b dot c plus c dot a becomes 0. So you will be getting mod a square plus mod b square plus mod c square. Very simple. So this is the special case you need to remember. So already completed both the years. This is the only revision I am doing, right? You can go through my previous videos. So this is very important, very important result we have deduced. So generally this is called super shortcut also, but moreover you remember, so you can deduct by your own. So this is mod A plus mod B plus mod C equals to, providing A bar, B bar, C bar are three mutually perpendicular vectors, that is equal to square root of, you can write mod A square plus mod B square plus mod C square. Clear? I hope it's very clear to you. Right. So next 22nd one. 22nd one. Let us move to 22nd one. Right. Let L1, M1, N1 be the direction cosines of A bar. So direction cosines of A bar. How to find out direction cosines of A bar? It's very simple. First find out the unit vector of A bar and compare to L1x plus M1y plus N1z, so that you will be getting L1 comma M1 comma N1. Right. So direction cosines of A bar, and whereas let L2 comma M2 comma N2 be the direction cosines of DCs. We can write shortly also, direction cosines of B bar. Then angle between these two and the angle between these two vectors, A bar comma B bar is equal to theta. Then we can write cos theta is equal to, very simple manner. If you know the direction cosines of the two vectors, then cos theta very clearly we can find out L1 L2 plus M1 M2 plus N1 N2. So if these two vectors are perpendicular, L1 L2 plus M1 M2 plus N1 N2 becomes 0. If these two vectors are parallel each other, then L1 by L2 is equal to M1 by M2 is equal to N1 by N2. That we have discussed in 3D also. Right. Next, let us move to equations, vector equations. 23rd concept now. The vector equation to the plane. The vector equation to the plane clear, which is at a distance of p units from origin and n cap is a unit vector Harini Pavan, right, unit vector perpendicular to the plane. Perpendicular to the plane. To the plane. Is the vector equation is given by r dot n cap is equal to p. R dot n cap is equal to p. Right. For example, if origin lies on the plane, this is special case, then the equation of the plane is r dot n cap is equal to p becomes 0. That's all. It's a special case. As a special case we can remember, right? So one more, 24th, right? 24th. The vector equation of a plane passing through A of A bar, that means position vector of A is A bar, and perpendicular to the vector, yes, and perpendicular to the vector n cap is r bar minus A bar dot n cap is equal to 0. So this you remember. So now tomorrow we are going to discuss more clarity about the remaining concepts related to this dot product of the vectors. Then tomorrow we are going to start the problems on vector product or scalar product. Thank you for watching. Bye bye. Have a nice day.